Hello, hello, hello. Cheers, Kevin here, and welcome back to Minecraft Agoraphobia, where our swimming pool is next to the bed. We're so claustrophobic. All right. Anyway, welcome back. I'm here on the same day, recording 2 episodes because with the holiday season, I figured it was probably best to try and get a bunch of stuff done. And when we last left off, we ran into a couple of bugs. We were trying to get this guy to move. We wrote a really fantastic move script, and we discovered, hey, we can't get it to work with our tests, and in the game. And we also discovered that, hey, we can't get him we tried to get him to repeat trying to do his movement if there's someone in his way, and he failed at that too. So, want to address those 2 bugs real quick before we move on forward. So the first issue we had was things not running with the test, and let me jump over to the code so we can take a look at some of that. So this is the updated version of the code. Now, what we had before, we had these tests that Android makes move calls in sequence. And so what we did is we said, all right, well, we know this Android thing is going to use robot. So we said local robot is a thing, and then we'd say function robot.forward and create our own, fake thing that robot.forward should do. So, be a calls made equals calls made, .f. So instead of actually trying to move the robot forward in the case of our test, it would just log to the calls made that, hey, he tried to go forward. And then we did that in a hope that we could get the Android the Android library to deal with that. Now, that was fine so long as we were relying on robot just sort of existing in the ether. But the problem is that doesn't really work so well when it comes to the actual situation. So what I've instead done here is I've had to do a little bit of craziness, because the problem is that if we take a look at the Android file, now it has to do this. It has to say local robot equals require robot, because otherwise if you require it, it gets all sort of confused. So it has to load up the robot class because it needs to know what robot.forward is and what robot.back is and all of those things. Now, that means that as soon as we require this file, it's going to look up robot and it's going to be like, all right, I know what forward is. And so if we want to create our own fake definitions that we can track what it called, well, then we have some issues, because I can't say, robot equals fake thing for test 1 and then require Android, and then robot equals fake thing for test 2 and then require Android. Because it's going to cache it. It's going to give me back the same Android, and when we required Android, even if we manage to stub out robot, it's still going to remember Android from test 2. So we've had to go ahead and do some hackery, and I've written a little function to do that, and this is local Android with robot. And what this is going to do is it's going to take this package system, which is how the require stuff works, is it's going to go, okay, package.loaded Android is going to equal nil. This is where it would store Android after it first requires it. So the way that this secretly works is that when you go ahead and you say require a thing, it'll go ahead and say, all right, I will go ahead and say package.loaded thing equals, run file thing. And then I will return package.loaded.thing. So it stores it there. That way, well, actually, no, it does even clever. If package.loaded.thing does not exist, then it does that, approximately, if I could write valid Lewis syntax, but it's going to return the thing regardless. That means that it doesn't have to run the file multiple times, and that's a good thing, but it's a bad thing for us because we want to be able to fake out some stuff, because we basically need to say, hey, Android file, when we run you, don't actually load the robot file, because there is no robot file in our test environment. We want to use a fake thing. So here's what we're doing. We said, all right, we're going to say, hey, if I say give me an Android with a specific robot, don't actually load the stuff. You have to know that Android doesn't exist and robot doesn't exist. Doesn't matter if I've already required them. Forget about that. Delete it. Next, I have package preload robot. And this is a function that we say, okay, if you look for robot, we're going to return back a thing. We're going to return back a stub. And what is the stub? Well, the stub is an argument that we have to pass into this Android with robot function. And then we're just going to return requiring Android. Again, now it'll be requiring it for the first time, quote unquote, because we've deleted it up here. So it doesn't remember that it's already pulled up the robot file. So it's going to go ahead or the Android file is going to go ahead and look it up again. Now, in our test, this means that we actually have to require Android inside the test. We can't just put it up at the top of the file and be like, we're going to use Android, so import that. Instead, here we're saying, okay, Android is, give me Android with this fake robot. And so instead of modifying robot, we're actually passing it in our fake definition for what the robot module should be. And here we pass it, all right, it's got to have a forward, a back, a turn left, a turn right, and up and a down, because we know we're going to use those. And then we can leave the rest of the test the same as it was. So there we go. And then here we've got the same thing. This one requires fewer stubs. So you've just said, all right, well, there's a forward and a back. And we just need to make sure that those are passed in. Now, this has to give us back a different... We need a different Android because it needs to refer to this calls made and not the calls made up in here. There's all sorts of confusing. Anyway, the point is, we go ahead and run this. And it, in theory, works. Why is it? Oh, actually, this is not going to work for the other reason. So the other thing that we did, and we did this at the very end of the last episode. Why the heck did I... Oh, yeah, I put this in here to test some stuff out. There we go. The last thing that we did, we put in here, repeat success error until success. Because we wanted to make sure, hey, if we are having trouble moving in a particular direction, well, that's a problem. And we want to keep trying to move in that direction. Now, we couldn't get this to work last time. And I discovered that it turns out it was just not loading the right value. It seemed to have somehow cached it, and so it wasn't taking the updates. Even though we were updating the file, it wasn't taking those changes. This actually does work. So we just say, hey, when you say robot.forward, this will give you back something. This will either give you back true, or it will give you back nil, and then some sort of reason. Some sort of error message. Error message. And so what we're doing here is we're saying, all right, success is going to be true or nil, and then give us back the reason when we call whatever function that may be. And remember, these steps are defined up here in the top of a file where we have steps. F is robot forward, B is robot back, et cetera, et cetera, et cetera. So I've gone ahead and modified both of our movement commands to repeat until we get a proper success value. But of course, that's going to break the tests because we're not doing any of that stuff in our tests. We're not returning true. So it's going to go ahead and it's going to say, hey, I didn't move. So yeah, we should fix that. Let's see if I can do that real quick. I think semicolon's going to work. Return true. That should work, maybe. Who knows? All right, good. The first one works. And then we can just do the same thing with the second one. Return true. And there we go. Now both of our tests pass because now, yeah, it has more of a tight dependency on, hey, this better work the same way that robot.forward is intending to work. Okay, so our tests pass again. That's good. And if we go back to the game, the game is gone. Where's the game? There we go. Hello, game. Now I'm going to go ahead and step out of the... Actually, no, I'm going to stay in the way. Now remember, the last thing we wrote was a little script that just, it goes up 2, it goes forward 2, it goes down 2, and it goes back 2, which are the only four things, the only four movement commands, I mean, other than turning, that it really does. So let's go ahead and run move test again. And it goes up 2, and here, now we can see it is trying to move down, and it is continuing to try and move down, despite the fact that it can't, because we're in the way. And as soon as I move out of the way, it finishes up. Lovely. Absolutely fantastic. Now this means that if monsters get in the way, they're not going to stop our program, which is pretty darn awesome. Now, one thing, though, that will stop our program is this. Yep, it is trying. It is trying valiantly to move up, but it is never going to be president now, as they say. Now, of course, if we get rid of that, then it will go ahead and do this. So we want to go ahead and update our function to handle that. All right. So basically, because it gives us back a reason why it couldn't move, we can check what that reason is. So let me put this back here. And actually, what I want to do, we'll just give it a whole deal. All right. Because those are the 4 movement commands that it has to worry about. We're just going to make sure that it can handle all of those cases. So this knows, this is basically, for this thing to pass now, it will have to be able to dig up, it'll have to be able to dig forward, it'll have to be able to dig behind itself, which is the more complicated one, and it'll have to be able to dig down if there are those things in the way. So, okay, now that we've got it in this tricky situation, let's go ahead and jump back over. Oh, and by the way, in case any of you guys run into this with the whole, hey, it's cached, it's not doing what it's supposed to do, just go ahead and, nope, rebotto. That would be interesting. Nope, go ahead and reboot, and it will beep at you, and then it will do this stuff. And then when you go ahead and run stuff, then the problem went away. So I felt kind of dumb. It could have been that I accidentally, it's because we had things open in both both in the game and in the Linux machine at the same time, which maybe caused, I don't know. But anyway, we may find ourselves doing some rebooting on occasion if we edit files and we see that it's not quite picking up changes. So let's jump over to the land of code, and we'll start modifying our stuff. Now, I'm not going to worry about using tests to do this because this is really just not a thing that we need tests for. Sacrilege aside. Okay, so here we have repeat, success, error is equal steps, direction. Right. And actually, I spoke too soon. Let's go back to the game. We want to make sure that we know what the error message is, right? So let's go ahead and launch Lua, and we'll say robot.up, and we'll show the output of that. Nil and solid. So we can do a comparison and see, hey, if the reason for not moving up is solid, if the error is solid, if error equals solid, then do a thing. Then do a thing. Okay, so here we have to do a thing. Easy enough. And we'll have to do a thing here as well for the multi-movements, or for the single movements, rather. Whoops. This is slightly more indented than we want. So if the error is solid, then, well, we need to go ahead and say if direction equals F, then, actually, let's see here. Lua, switch statement. Yeah, we've already looked this up. We're going to go ahead. No, Lua lacks that. Right. Okay. Right, okay, if direction equals this, then robot.swing, I think. Else if direction equals up, then robot. We'll change what this actually does. Else if direction equals down, then robot.swing. Else if direction equals back, then, whoops, robot.swing and end. Okay. This is totally not going to work, but I think this is the right sense. Okay, so up, I think is swing up, down is I think is swing down, and this is I think, well, this is not going to work at all. So let's go then, and then we'll put an end here. So, because back is confusing, we got to say robot.turn left, swing, robot.turn, because we can't swing our axe or pickaxe or whatever in that direction. We need to turn around, clear it out, and then turn back. So that's the complex case, which is less fun. Let's go ahead and just steal this block and just see if it happens to work. It may not on the first try because I may have some of the syntax wrong, but hey, that's what experimentation is for. Boom. And no reason to have copied that over when we did. Let's jump back to the game and see. Come on, game, where are you? There we go. All right. I'm going to go ahead and reboot just for safety. Reboot. And then we'll say move test. Now remember, move test is very, very, very simple. If we look at move test, and by the way, I have added, I have just copied edit to Vim so that we will not end up with that issue of me not. Yeah, so okay, we require Android from SRC Android, and then we say, hey, Android.move, up to, forward to, down to, back to. And all we're doing is we're modifying the Android file. We're not really modifying this test. This is just taking the thing through its paces, so that's fine. Let's go ahead and run move test. There we go. Now, of course, you'll notice it does try and move first. And then, so it has to fail once. Oh, now it turns around, now it turns back, and there we go. So there we go. We did it. Hooray for us. Let's put these back, because I want to clean up that code, though. And actually, one thing that we haven't tested, let's see. I want to, so one thing that's possibly an issue is that these commands run a little bit differently depending on when it's running a single thing or a thing with numbers, just because the way that we have stuff structured. So I want to change one of them to be using the single keys rather than the multiple, because that whole branching logic is a little bit different. But that's all right. Okay, so let's go over to the code and see if we can tidy this up a little bit. Make this work a little bit better. Now, what we did last time, well, what we did for this line is we just said, hey, we're going to put the movement command in a little dictionary. So let's say clear is this. And I'm going to say, we're going to do the same thing. So in this case, we don't need one for all of these. We just need commands for forward, back, up and down. Up, whoa, nope, and down. And they all need to equal things. Function end. I'm just going to do that for now, and then we'll have to put stuff in there. I'm going to go ahead and split so that we can take a look at what we wrote initially. And then we also don't have to worry about, hey, did I copy and paste this exactly the same between the two? Because we'll end up just doing something like if error equals solid, then clear step, right? Actually, clear is a little bit of a tricky word, I think, or it's a dangerous word. It's probably fine, but I don't want to risk it. What should we call that? Break doesn't make sense either. How about clear block? Okay, so clear block. And then this whole chunk of stuff can go away because we'll just put that all up in here. So forward was just robot.swing. And of course, we could actually write tests for this as well. We could say, hey, if you fail, then make sure that robot.swing happens. Let's see, robot. All right, this is the complicated one, so we'll actually put that down to the bottom because that's going to be multi-line. Up is just robot.swing up. Down is robot.swing down. Sweet chariot. And there we go. We'll just steal that. And dedent. Too far. There we go. And hopefully that's valid code. Who knows if it's valid code? Well, I do. We actually can use our test. Even though it's not testing this behavior, it should at least complain if things don't... Nope. That's right. If things don't compile. And of course it is... my syntax highlighting is angry. That's fine. Hang on. There is a way to do single line ifs. Lua, single line if. If then else. Do. Oh, just put an end there. Right, got it. End. Done. And we'll just put that same... Oops. No. Where am I? 11 up. There we go. Put that same thing here, and we'll get rid of these things. There we go. Much nicer and shorter. Now we've got all of these sort of cached commands up here, and we can go ahead and take a look at our Android test and see if it still passes. It does not. Error loading the file. Unexpected blah 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 blah. Okay, so let's fix the unexpected blah 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 blah. Oh, yep. There are no commas. Always have commas, kids. Do not forget your commas. And actually, let's make this look pretty, right? Why not? Code could look pretty. All right, nope, can't run that file. Can run this file. And look, our tests are passing again. Let's jump back into the code world. Or not the code world, what am I talking about? Move test. Actually, no, I want to reboot because I won't even know because the existing version was just fine. And oh my goodness, it's nighttime and I'm awake, which means things are going to be spawning. All right. Move test. Uh-oh. No! Attempted to call global clear block a table value. Heavens no. All right. Let's jump to the code and see what we did wrong. Steps clear block. Then clear block step. Oh, whoops. So here's the problem is that we're saying steps direction here. Because that's the issue. But basically, when we split our total, so we have this whole F2, D, B, whatever thing, that becomes, that we end up assigning a step is F2 and D and B. And then if it's an F2, then we say direction equals F. And then there's some num, N equals 2. Well, 2. So in the singular case, we don't end up renaming it direction because there's not really a reason to. So yeah, the code is just a little bit slightly different. So, okay, clear block direction, but clear block step in the case where there is not a number. Go ahead and save that off. And then, yep, I hear you, Spidey. Let's go see what you're up to. All right, where's the spider? Oh boy, it's loud though. I will give it that. All right, let's do it again. Nope. Okay, so oh, there's a spider. It's clipping through the doorway. All right, so yeah, it does need us to reboot. That's going to be a little... Well, it's fine. Move test. Nope, still. Clear block a table value. On Lua. Move test 2. Android line 33. Okay, what's up, Android line 33? Line 33. Clear block direction. Clear block direction. But we had no problem with that before. Oh, whoops. Yeah, no. This syntax is wrong. Clear block step. Yeah, because we're not passing that in as an argument. We're saying, hey, get me this one, and then call that function. All right, stupid Kevin. Stupid. All right. Will that work? Nope, same error. Fine. Reboot. Does not like me making changes. All right. Hello, Spideys. How's the Spideying? We may need to turn the volume down because this is gonna get old real quick. All right. Move test. There we go. And now you're back to normal. I want to put this one back here. I'm also going to stand in its way. There we go. I want to see that it can test both of these. So it moved, and now... So, okay. See, now it's not going to try and clear me because it knows that I'm not a block, but it is going to still try and repeatedly go this way. And now it's got to do that whole turning around thing, and turning around, and it gets back to where it's supposed to be. Fantastic job, Vinny. So, let's see here. Let's actually look at our different script, right? What was our what? Not our what? Yeah, let's. Oh man, I can't open multiple things at the same time. But what I can do, let's see. Let's jump into our code real quick, and we'll write an actual use for this. Let's just try and get it out of the house using our new syntax. So remember, our water here are the lines that it took for us to get out of the house, and then just getting back in the house from the same thing. And remember, we had to write this. We basically wrote a forward and we wrote an undo, and then we just put all these things in various little chunks. And some of these we've said, all right, well, there are 4 backs, so we started using for loops. We started using instead of having robot.back 20 times, we ended up doing that just to try and clean this up a little bit. But let's do a little bit better. So let's say go outside. Yeah, go outside. Let's see, outside.lua. And we will say, just like we did with move test, Android is going to do this. And then all we have to do is we'll look here. Robot swing down. We don't need to worry about robot swing down. It will swing down if there's stuff. It won't if there isn't. So we'll say Android.move. We'll say, well, let's just copy. We'll copy this junk, right? Do this. Good. Place up. Ooh, I do want it to place up. So actually, we want to treat these as a little bit different. All right, so Android.move down to robot.placeUp. So we do need to require robot as well. Local robot equals require robot. And now we've replaced this. Oops, no, robot.placeUp stays there. Okay, so we've got this, which is just going down and putting a block ahead so it doesn't leave a hole in the floor so that we could fall into and die a miserable death. And now, let's see here. We'll just say Android.move, and we'll say, let's see, left 2, forward. Let's see. Okay, left 2. We'll get rid of the swing because there's no reason for any of that. We'll get rid of the swing up. Okay, so forward 3 and up 2. There we go. That's all that did. Now we've replaced that. Let's look at the water stuff, and we'll grab the get inside the house stuff, and we'll put that back. Let's see. This moves down 2 and then places up. Now this gets to be a little bit different. So okay, because we don't need to place something up. We just need to place something down at the very end. So let's see. Up 2. Left 2. Okay, so we do have it turning around. We don't technically have to have it do that, but I think it probably makes sense to have it do that. Okay, let's write this. We'll say Android.move down 2, back 3, up 2, left. Does it have to go? Yes, left 2. and robot.placeDown. All right, and we'll say, get inside the house and leave the house. So from its starting position, this now should replace, what, 70 lines of code, something like that? We've now got that down to 10 lines of code. And we could do, if we weren't worried about placing blocks and stuff, we could do it even cleaner. Let's just double check that that works. All right, game. Let's see if you're up for it. So outside. There we go. Hi, Vinny. Fantastic. Love it. Wonderfully done. And of course, it's not doing any sort of block closing over there because we didn't tell it to. We don't particularly need it to. Now, this does mean we can finally start using this library for all sorts of cool stuff, like planting a little bit of a farm. In fact, I want to do that right now. I want to edit our script. I want to add some more commands. Let's see. So when it gets out there, it's facing away from us. So we'll tell it to turn to the left, and I want it to go forward. Let's see, 5 blocks. 1, 2, 3, 4. Yeah. Okay. Let's edit outside. Oh, nope. Edit outside.lua. And I'm going to say mow the lawn. Whoops. Mow the lawn. So what I'm just going to have it do one track of this. I'm going to say android.move left, forward 5, left. And then I think I actually want to have it do a loop. I want to say go back. Actually, no, we'll test how this goes. Forward 10. And then go back is going to be android.move. Back 10. Back 10 and then okay, so turned left, turn to the right, back 5, turn to the right. That should be okay. Why do I feel like that's not okay? Something is going to go terribly wrong. Let's see what happens. Outside. Look at that. Okay, it's coming back. Turn to the right. Yes, okay, good. I was right, I think. And now it's gonna come back inside. Yes! What did you get? Did you get any? You didn't get any? That was not some great lawn mowing, buddy. All right. Let's do one more edit. I wanna hopefully get some seeds. That'd be convenient if we could get ourselves some seeds. All right, let's do 20. And we'll change this to 20 as well. We'll have it just to be super safe. We'll do this, and then let's see. Can I? Fine. We'll pop over to the code world. Close this. Open up outside. Oops. Open up outside. All right. So we've got this. Mow the lawn. Do this, and we're doing this in a very inefficient way. But I'm gonna just change how many it goes. I'm gonna change that to 6. I'm gonna change that to 6. I'm going to do this, 6, change that to 7, change that to 7. We're just going to clear the grass and hope that we get some seeds that way. Who's to say if it will actually work, but this should at least do 3 strips. And actually, let's do one with 4 blocks forward as well. And replace that to 4. And of course, we don't need to be doing all the backtracking that we're doing, but hey, we don't have a nicer pattern to do this, and I just want to be super, super careful so that we don't end up doing anything too crazy. Okay, good. 4. Good. All right. Game, set, match. Let's reboot you. Make sure that you've taken the relevant changes, because we really do need some food. We've got nothing to eat. We got a little bit of coal. Oh, we do have some seeds. Well, okay. I would like some more seeds, though. Let's go outside. Go clean up, please. And that creeper is looking awful creepery. All right, good job, Vinny. Oh, it's gonna go further, isn't it? Yep. He's gonna start digging over there. I hope it doesn't run into anything it can't clear. That'd be very unfortunate. Uh-oh. Uh-oh. Oh, no! Oh, no, what's going on? What did I do wrong? What did I do wrong? I done screwed up, guys. Okay. Come back, please. What is it doing? How did... Oh, no. All right, well, okay. We may need to go out... we're cheating. This is a non-recoverable type of error. Let's create another chest, I guess. While we're here. Save absolutely everything in there and just go out without any protection whatsoever. Oh man, that's not good. And we can't even, because there's a creeper out there. I don't know what it's doing, but it's stuck. All right, well, that is going to have to be something that we deal with in the next episode. Oh man, I was really hoping we'd get further in without me having to cheat and go outside. And not only that, we're going to have to like break blocks and stuff, because it's probably, how many blocks is it? 10? Yeah, it's probably going to be pretty far away. Let's look at the code real quick. Was there something obvious that I missed? Forward 20, back 20. Yeah, so I'm guessing it must have... Yeah, no, it must have just found some case that it couldn't... Like some block that it could not break and got stuck that way. Huh. Or, oh, you know what? There's another reason. If it ended up finding a cavern, it may not be able to move forward, but that wouldn't be any sort of cost. It'll keep trying to move forward even though it's not allowed to. All right, well, we will have to discover the fate of this poor little guy in the next episode. Until then, cheers.